Hey everybody, how you doing today? Oh, sorry, I got that light on. Give me 1 second. There. Otherwise, it's real shiny over my shoulder there. So sorry to be missing you in person. I went out to the van this morning, and I've got what I'm assuming is some sort of brake fluid all over my right rear wheel, and it smells real stinky. There's like some sort of thumping noise last night, and I hate vehicles. Like, I know nothing about mechanical stuff, so I figured I probably shouldn't drive it into Dearborn, given I don't know if the brakes will actually do anything. So, so sorry for missing you, but hopefully this will be okay. I can catch you this way. So we got a couple things on tap today. Let me grab our schedule here. So Project Zero was due today at 12:30 p.m. So hopefully you all got a chance to get that one in. So we'll go over Project Zero, over the solution to it, talk a little bit more about loops, and then we'll look at Project One as well. So we got through most of loops. There's just a couple last little things I want to talk about with loops, and then we'll get into Project One. That sound good? I'm going to go grab Project Zero here. Yep, due today, 12:30 p.m. Fantastic. Good, 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 good. All right, so we're going to build the store and then sell stuff from the store, essentially. Right, we got the rubric here, so I'll just check the boxes here on how that's all going to get graded. So let me fire up PyCharm. Can remember the right tool here. Got a lot of tools, friends. It's okay. All right, so we'll start up a new project here for Project Zero. Come on, there we go. I'll call this one Project Zero. And we'll create it here. All right, so part one says we need to go and ask them, hey, what are you selling? What's the name and quantity and price of 5 things that we're going to sell? Add those to a dictionary, and lots of different ways of assigning this other data to it here. Lots of different approaches, and really any way you took, as long as it uses the dictionary, I'm cool with. I know somebody used 2 different dictionaries, one for prices and one for quantities, and sure, that'll work. I had assumed you'd use an associative value that stored both things, but that's okay. It totally works. I know a couple of people I helped used just a list, and we said, hey, the first thing in the list will be the price, the second thing in the list will be the quantity. That's awesome. Or my preferred approach is using another dictionary with keys of price and quantity, and then associative values of the actual values here. So it's like a dictionary inside of a dictionary is my preference, and that's how I'm going to solve it, because I think that makes the most sense just for us in programming. So I don't have to have that mental load of like, okay, I know the first index here is always going to be price, or the second index is always going to be quantity. But lots of different ways about solving it here. Not necessarily just one right way here. All right, so we're going to have our store essentially is going to be an empty dictionary. And then we're going to ask the user for 5 things. So you didn't need to use loops, but you're welcome to use loops. So we could say for item in range 5 here, we'll do something 5 times. Now the value of item is going to be 0, and then 1, and then 2, and then 3, and then 4. I don't care what the value of item is. I just want to do something 5 times. So that's all I'm using the loop here for. So we'll have a name is going to be an input of, enter the item name. And then we'll have a price is going to be a float of an input of, enter the item price. And then a quantity is going to be an integer of an input of, enter the quantity you are selling. A quantity of the item, sure, I don't know. And again, if you wanted, right, we could probably use name here instead of item price, right? We could say the price of, and do this as a nice little formatted string. Might be cute, right? Quantity of name here, right? And we can throw those in here. That'll look kind of nice. We can use the name. If you wanted to say like item number 1, item number 2, item number 3, you could, and maybe that's why we could use this item value. But either way, I think this will work out fine. And then once we have it here, we're going to take store. We're going to add a new key of name. Hey, sorry, I'm terrible with names, and Twitch handles trip me up even more sometimes. So the store dictionary key of name will probably be a new entry. I mean, if I ask you to enter the item name and you enter apples, 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 I'm going to be overwriting the value. And Okay, that's fine. I didn't ask for any sort of sanity checking here, making sure it didn't already exist. So we'll just say, hey, let's go set the value of this equal to another dictionary of, I want the string for price as the key, and the value of the price variable as the value associated with the key of the string price. And then we'll have the string of quantity here with the value associated of the quantity. So I'm going to use a dictionary inside of a dictionary. So the value associated with the key of name is another dictionary with values for price and quantity as keys. The values associated with those keys are the actual price and actual quantity of an item. So we'll do that 5 times. So if I were to have, say, an item like apples, I could say, hey, store key of apples, key of price, would give me the price associated with the apples, right? So it's the value associated with the key of price, which is the dictionary, associated with the value of apples, here, the key of apples in the store dictionary. Again, one option here. I guess we'll leave it this way. So other people said, hey, I want store key of name equals just a list, and they said price and quantity, right? So then to get out price, it was store key of apples, index of 0 for price, right? If they used that index notation. So I found this a little more awkward, I suppose, but they both work. So any way you prefer it was fine here. Okay, and that's it for part 1. We have now set up the store, right? Now we need to sell stuff. Ask the user how much money they have. So we'll have, I don't know, total money equals, that's probably a float. If you just did an integer, that's fine too. How much money do you have to spend? Okay, well, now we have their total money. Well, 5 times ask them what they want to buy and how many. So again, probably another loop here, because loops are easy. If you didn't use a loop, that's okay. No worries. No problem here. You just have the same code more than once and feel bad about yourself. But we just learned about loops, so that's okay. You don't need to go like modify a working program if you already had it done. So we'll say, what do you want to buy? So we'll say, I don't know, the name again here is an input of do you want to buy? And then how many, right? A quantity is an int of an input. How many name you want to buy, right? And do that as a little formatted string. So how many of those do you want to buy, right? I want to buy 7 bananas. Great, sure. Now, I didn't ask for it explicitly that we check to make sure they have the item, but we could, right? We could say, hey, if name not in my store, we can print, you don't sell that. Otherwise, right, else, then we're fine. Either that's okay. And you could just say if name in store do the thing, else print. This is just totally a style preference here, that this is my error first here. Okay, otherwise, we do sell it here. So then we need to see if they have enough money for it. Right, so we need to get the price. So then this will be the money needed, then is going to equal the quantity times the store key of the name. Right, so hey, you entered bananas, go get the value associated with bananas, which will be a dictionary. Go get the value associated with the key of price. So go get the actual price associated with the key of price for the item in my dictionary with the key of the name, the thing you want to buy. Okay, and then we can check. We can say, hey, if money needed is greater than the total money, we'll print you don't have enough money to buy that. Otherwise, now we need to see if we have enough to sell, right? Check to see if we have enough to sell here. Okay, so now we can check. Maybe I could even do that in an elif, I guess, here. If the quantity is greater than the store key of name, value associated with the key of quantity. If you want to buy more than I have here, we'll print, oops, we don't have enough. Or maybe we can say we only have, and then we'll do a little formatted string here, because formatted strings are fantastic. We love formatted strings. Quantity available. Oh, so we should do this in single quotes here. That'll make that a little happier, right? We only have, well, what is the value associated with quantity, the actual quantity, out of the dictionary that's associated with the key of name? Right, so it's a lot of practice using the dictionary here, which is it's a different way of thinking. So I have some key and a value associated with that key. If the value associated with the key is another dictionary, I can get another key and get the value associated with that one. So it's a little silly here, but it's a quick, easy way for us to store some information here. So we'll check, okay, if you have enough money, or if you don't have enough money, you don't have enough money. If we don't have enough quantity, we don't have enough quantity. If you have enough money and we have enough quantity, great. Now we'll go and reduce the quantity here and reduce your money. Right, so we'll take our total money, and we're going to subtract the money needed. And then we're going to take our quantity, and we're going to subtract the quantity that you wanted to buy. Right? Quantity minus the quantity. And maybe we should say this. So I could rename it here, but then I'm using it a lot of different places here. So a little hint here: you can right click and say Refactor Rename, and we'll say quantity to buy here, and it's going to rename it everywhere for me, so I don't have to do that, right? Because I'm lazy. I don't want to do more work than I need to. So I'm going to use the tool here to rename it for me. So now my quantity to buy, quantity to buy, quantity to buy. This sort of cleans that up a little bit, if that makes sense. Okay. Then, right, we need to be tracking the cheapest and most expensive and the total spent. So, and we're going to display a receipt of every item they purchased. Most expensive, cheapest item, total cost, money remaining, and then display what's left in the store. Right? So, wow, that's a lot of things. So if we need some sort of receipt, right, we can add something here to something. So, okay, that's really vague to say something to something, but what if we just had a list for a receipt? Right, so if I'm tracking a receipt, I can have a receipt is equal to a list, I suppose. We could do that. Sure, why not? And then if we want to track the most expensive item and the cheapest item, and again, I was looking at per order total, like, I bought 10 bananas is more expensive than buying one pineapple. Sure, but like one pineapple costs more than one banana. So I was looking at quantity times price, but any way you wanted to do that was perfectly fine here. And the total amount spent. So, this is going to be a little weird here. Trying to go about it this way. Back to my friend, thank you so much for donating those bits to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. It's a pleasure having you along. So, a couple different ways we could go about that here. Okay. The first thing we buy is the cheapest and the most expensive. That one's pretty easy. Other than that, we need to see which one is more than the cheapest or less. No, I'm sorry, less than the cheapest or more than the most expensive. Or if we just track them, right, you can use min and max, which is pretty nice and easy. But if we're doing that, we don't necessarily have the like a string value associated with it here. So a couple ways are a little fun here. So I think with the receipt, we can just print out, you bought 10 bananas, right? Every item that was purchased. Getting the most expensive and cheapest is a little bit different. And then total cost, right? We'll have to add some total cost, money remaining. So lots of different ways of going about it here. So I think the easiest way to do it here with a receipt is just using a list. Okay. And what we can put in the list is we can put then a price, right? And then we can put a string value here. This is, again, lots of different ways of going about it. So maybe we do receipt costs, and then we just do receipt, I don't know, names, I don't know, items. How about items? How about we do that? So if we track just the cost and we track just the items here. So if we go and buy it here, then we'll take our receipt costs and we're going to append the money needed. Right? This is how much it cost to buy that item. And then my receipt items, then we're going to append a little formatted string here of, this is the quantity and the name, like 7 bananas. Quantity. Quantity to buy. There we go. Quantity to buy. And name. A couple different ways we could have gone about that, but that's okay. So when we're done now, we can just use max and min on my receipt costs here. and it should just work, right? To get the total, that's just sum, right? So it makes doing some of these a little easier here. And then we need to, our money remaining, right, is our total money. So when we're done with all of this, right, after we bought our 5 items here, we can print then the all items bought, the cheapest, most expensive, and the remaining money. So to print all the items bought here, we can say for, this is item in my receipt items, we can print item. And then we can say, we can print the cheapest item was, let's see, I guess maybe we should add in the cost here too. We could add in like dollar and then the money needed. That might be nice, like 7 bananas and then the dollar price. That's probably nice. So then cheapest item was, as a formatted string, we can just do the minimum of the receipt costs, right? My receipt costs. We'll take the smallest value. Now, if we wanted to associate that with the receipt items, we could, right? There's a couple ways of going about it here. So we looked at lists a little bit here in our sidebooks. So one of the things we could do, and I think we kind of rushed over this one here because there's like a lot of things going on with our lists here. Where's our lists? We could make lists. We could access them by index, right? Update items. We could add or remove. The index of something here. So I didn't spend a lot of time looking at this here, but I can tell you, hey, what index matches this value here? So what I can do then to get that value back out here, so we could say this is the index of the cheapest item is going to be my receipt items. No, I'm sorry, is the receipt costs dot index of the minimum value here. So minimum of receipts cost will give me the smallest value. Asking for the index of that will tell me what index it is here. Then I'll have the index of the cheapest item. So because I'm adding these things at the same time, they should have the same indexes here, right? So here's the cost. We probably don't even need that here then, right? We can just say, hey, I want my receipt items, because we're already including that here. My receipt items index of the index of the cheapest item. Now, again, this is going above and beyond. If you just said this was the cost, that's fantastic. Just the numeric value was okay. I just think this is fun, right? And we can do the same idea here now of the most expensive item. Now we want the max here, right? Oops. So we'll use a different index here. So the most expensive item was, and we'll get the index of the most expensive item out of the receipt items list. Okay. And then what else do we need here? We needed total cost here. So then your total cost, we can print a formatted string of total cost here then was the sum of my receipt. Am I spelling receipt wrong? Receipt costs. I don't know why it's not suggesting it for me. That's okay. Was it just the sum of the receipt costs? Maybe we even print that like up here because that probably makes more sense, right? Here's your total cost. Here's your individual items. Here's your cheapest. Here's your most expensive item. And money remaining, right? So we can print, you have, right, as a formatted string, total money remaining. Hey, thanks for following along. Glad to have you here. Okay. So again, I'm taking a lot of shortcuts here because I'm familiar with these things. A harder way of going about it here, you might have had, the cheapest item was like, say, some really, really large number. And then you could say, hey, if the money needed is less than the cheapest item, then the cheapest item now is the money needed. Right. And we could just keep track of it this way. Like that's probably the, I don't want to say easier, but maybe a naive approach. Naive? Did I spell that wrong? Come on. Oh yeah, I did. Oh my goodness, naive. I hate that word, naive approach, but it works, right? Same idea, and then we just have to do with most expensive item, right? Start at 0, and then if it's more than, right, if money needed is more than the most expensive item, the most expensive item is the money needed. It's some sort of way of tracking these values this way here. And again, if we didn't have these lists, though, it might be hard to pick out a nice needed one. But again, you didn't need to give it the nicely formatted string here of adding it all to the receipt. You got lots of different ways of going about it here. I don't want it to sound like this was the only way or this is exactly what I was expecting. I just want to show you what's there. And then to display what's left in the store, well, that's actually really easy here. So we can print the remaining store items and quantities. We can just print store, right? That's a dictionary. If you wanted to loop through, we could, right? That's the cheap way, or we could say for item in store, right? And now this way, we're going to get the keys associated with those values. We could say, we could print the, again, a formatted string, because this is easiest here. The name, I'm sorry, this is the item here is going to be the key, right? And then this will be the store key of the item, key of quantity here. Oh, sorry, double quotes, because we already have single quotes here for this formatted string. Remaining. No, and the curly brace. That's what I did. Curly brace was in the wrong spot. Okay, so the item is the key as we're looping through the items in the dictionary. The value associated with that is another dictionary. I want the value associated with quantity to tell me what the quantity is here, right? That's what's left in the store. You could add price too if you wanted, but you don't really need to. It just wanted quantity, but it should print when we do store here, but this will print a little nicer, right? So let's try it. Okay, not too bad. What is that? It's 58 lines of code. Again, that's just one way of looking at things. It's not really a measure of a lot of things, but some people like looking at number of lines of code. Let's give it a run. See if it works for us. So what should we sell here at the store? So this is the audience participation part. You folks in chat can join in, tell me what we're selling and how much it costs and how many we have. We'll get them to our dictionary. I'll just drink some coffee. I know there's a little bit of a delay, I'm sorry, with the streaming here, but usually it's just a couple seconds. So you tell me, what are we selling? Oranges, you got it. Oranges, and how much do oranges cost? We'll get to coffee. Thank you, Kylie. How much do oranges cost? $3, okay. And how many oranges do we have in stock? 8 oranges. Okay, awesome. And then coffee. Yes, we have to sell coffee. You sell coffee for $4? Wow. I guess like the fancy coffee drinks, yeah, but like just a cup of black coffee. If you're charging me $4, I'm going to be a little sad. So how many coffees do we have, Kylie? And if we sell a lot of them at $4, we're making a good amount of money, right? Because it doesn't cost you that much for the beans, and water's probably pretty cheap too, I'd imagine. And then of course, you have to pay for someone's labor, pay for their time. So that's all well and good too. And what else are we going to sell, other folks? Let's see. We got some people in chat here, right? Yeah, we got a decent number of people in chat. We should be able to get a couple more items. What else should we buy? Or what? No, I'm sorry. What else should we sell? And then how many of them and how much do they cost? All right, apples. Okay, we'll get to that in a second. Thank you, Cadenza. Or Cadenzia. 20 apples. I like it. We got apples. We got coffee. We got oranges. All right, let me just throw a number. We'll just say we got 10 coffees here. We can get to apples. They cost $1.50, and we got 20 of them. All right, what else? What else do we have? Oh, 10. Okay, perfect. Look at that. I guessed 10. Awesome. We're going to sell hot dogs. I like it. For 99 cents each. Okay. You're going to undercut Costco there on their hot dog special. All right, and one more item, right? So we've got oranges, we've got coffee, we got apples, we got hot dogs. We need one more thing to sell. And then, of course, we have to go buy these things too. That'll be fun. We can go eat them all. I was telling my kids about the hot dog eating contest. The amount of hot dogs someone can consume is ridiculous. Like, I don't understand physically how that can happen. All right, pizza. I like it. For $3. Oh, you're selling some cheap pizzas there. There we go. $3 pizzas. All right, so how much money do we have to spend? Probably a decent amount of money, right? Maybe we should start with like 20 bucks. And what do we want to buy? What items do we want to buy? Stella, what are you doing? Stella, stop. You're knocking things down. Baby cat. All right, my cat's causing trouble. So what should we buy first? So we got to get less than $20 worth of item. Oh, maybe I should have done more than $20. That's okay. We can buy like 2 of things. Oranges. Okay, let's buy some oranges. How many oranges do you want to buy? So we have 8 oranges. They cost $3 each. Maybe we just buy like 1 orange here because they're kind of expensive. Okay, what else do we want to buy? Yeah, I just like physical space in your stomach, like for fitting 60 hot dogs or something, like ridiculous amount of hot dogs. I just don't understand even like the physics of it. Coffee. Okay, so let's buy some coffee. Yes, we have to buy some coffee. I want like 3 coffees here. That's gonna be like $12. Maybe just 2 coffees. Oh no, it's just knocking down my artwork. 2 coffees. Okay, cool. So we're in pretty good shape. Now maybe we should have told them how much money we have in the top of this loop, but that's okay. Buy a hot dog for $1. 1 hot dog. Sure. Uh-oh. We don't sell hot dog. Oh, we sell hot dogs, right? Hot dogs for 1 hot dog. There we go. All right, so we messed that one up here. That's okay. All right, what else do we want to buy? One more thing then, I think. Pizza. 2 pizzas? Or let's buy like 10 pizzas and make sure it tells us we don't have enough money, right? So when we tried to buy 10 pizzas, we don't have enough money for that. Okay, so we bought 1 oranges for $3. We bought 2 coffees for $8. We bought 1 hot dog for 99 cents for a total cost of $11.99. The cheapest item was 1 hot dog. The most expensive item was 2 coffees. We have 801 remaining, and the remaining store items and quantities: oranges, price and quantity, coffee. That's not like the prettiest looking output, but it does output all the data we need here. Excuse me, right? Because we had 5 pizzas. We didn't end up buying any pizzas, right? Because we didn't have enough money for them. But we did buy a hot dog. So hot dogs should have gone down by 1. Oh, we can look at it this way, right? Hot dogs, we only have 14. We bought 1 of them. We bought 1 of the oranges. We bought 2 of the coffees. So it seems like everything is subtracting properly here. All right. Questions, thoughts, concerns? This makes sense. I know using dictionaries and using lists and these sorts of things, it's going to take practice. And that's why we have the practice. That's why we're doing this. Yeah, this definitely smile. There's ways to overcomplicate it for sure. And that is one of the interesting parts of programming is this idea of being able to focus on just what the requirements are, just the things that we need. There's this idea, and you'll learn more about it as you take some more classes and look more about like software engineering. This idea called scope creep, like where the scope of the project, the amount of work that you're doing increases. It creeps. It's like, oh, it'd be really easy to just add this one other feature, or I want to do this one other thing, or I want to do one other thing here. Or if you don't have very clear requirements, like what specifically does my program need to do, it can be a little trickier, right? So that's more of like a software engineering side of things, of making sure we have the right design before we go and build something. So time that you spend planning your code is never wasted. I mean, it can be essentially, but for our purposes, the more we think about what we're going to do, and the more we kind of like talk through it in English steps and say, okay, I need to do this, and I need to do this, and I need to do this, before we start writing the code, is going to make it easier to write the code, because the hard part of programming is making a problem simple enough for the computer to do it, right? Telling the computer to do something, it takes some syntax and you have to know the right commands and things, but the computer will just do what you tell it to do. But it can only do small things. So you have to take a big problem and break it down into smaller and smaller and smaller steps to figure out how exactly do we make it do what we want it to do properly. Okay, so I'll get this committed to the GitHub repository here. And then we'll go back to loops. We'll talk about loops for a little while, and then we'll talk about the next project. This is project 0 complete. Okay, fantastic. All right, so we open up our loops project here then. We'll go back to loops. Okay, so we had some fun with printing some ASCII shapes. I think we did that with our lab. We had some practice building some of those. So a couple other things with loops I want to show you. So range actually does a couple other things that we've used it for. Right? It will start at 0 and go up to and not including this. But range, you can give it some other values. So I can say like for skip count in range, and then range, you can give it a couple things. So I can give it a starting number here. I can say start at 1, please, end at 11, which will be up to but not including 11, and then how many do I want to skip? Right? Usually we count every 1, but I can say, hey, let's count every 2 here. So now I can print my skip count. I'll get 1 and 3 and 5 and 7 and 9. Right? It's going to go from 1 to 10. So the start is optional. The end is required, and the count by is optional. Right? So where do I start? Where do I end? What am I counting by? Usually we just say, hey, where do you end? Right? That's the only thing we give it. But now if I want to print my skip count here, we'll get 1, 3, 5, 7, 9, which is fun. So we can make range do more things for us. So range is really powerful. You can also, if you want, count backwards. Backwards count in range. So if I want to start at 10, I want to go down to 0, I want to count by -1. I can print my backwards count. Right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, and then blast off or something, right? So start, end, counting. Count by. So what you can't do, though, is add a count by and not a start, which is a little unfortunate here, but that's okay. So if you want to count by a specific value, you have to tell it what you're starting at, because otherwise it just gets 2 numbers and it gets really confused, right? If I just say for value in range, if I wanted to say 10, count by 2, this is not going to do what I expect it to do. I don't think it is. Pretty sure it doesn't. Yeah, this doesn't do it, because what it interprets this is as, doesn't work. It thinks the start is 10 and the end is 2, right? And if you don't tell it to count backwards, it's going to try counting up and say, oh, well, I got past the end, there's nothing to count, right? So if you want a count by, you have to include count by, have to include start and count by. So it's a little confusing here when you do these, but it'll work. So if it's not doing what you expect, check it out. Hi, Stella. Stella wants to say hi. You're causing trouble, lady. Getting into all the things. So range is nice, really handy at doing that sort of thing, counting different sets of values and that sort of thing. Works really well for you. Hi, baby. What do you need? Go upstairs and play with everyone else. No, she just likes to hang out my lap sometimes and get into trouble. You want to say hi? Say hi to everybody. Say hi, class. I'm a cute cat. She's purring. I don't know if you can hear that. Maybe. Oh, okay. Sorry. You didn't like that. Sorry. All right. Anyway, so range is nice. So some other cool things we can do with loops. I'm not really fond of these operations, but they have some really nice cases where they might be useful. So while we're looping here, I can say something ridiculous like while true. I'm sorry, capital T true. And now I have an infinite loop. And we'll ask them to enter a number, is an int of an input, enter a number, and I can say, hey, if number is equal to 42, break. Now, break means end the loop, hard stop. It just, as soon as you get to the word break, the loop that it's inside will stop running here. That's what it does. So break is used for stopping a loop, hard stop, bail out, we're done here. So it looks like an infinite loop, which is generally bad form here. What? Remove redundant parentheses. Oh, that's right, sorry. The parentheses are silly. Yeah. So if I run just this here, it's going to ask me for a number, 1, 2, 3, on and on and on. You can guess a number. Eventually, if I give it 42, the loop stops. We're done. Right? Game over, because the loop was done. So breaks, they can be useful, but again, I'm not really fond of them here, and that's okay. So the other thing we can do, another special keyword you can use is continue. Continue doesn't end the loop, but it will jump back up to the top of the loop here. So if I want to say, let's say, while, let's say number equals 1, and while number modulus 2. Now, this is silly. Remember, Python is truthy, right? Python is truthy, 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 truey, truth, truthy. I don't know. So every value is true or false. So remember, 0 is false. Anything other than 0 is true. So if the number modulus 2 is not 0, it's true, that means it's odd. So number equals an int of an input, of enter an odd value, right? Okay, if we enter an odd value, the loop keeps going. Oops, sorry, we gotta get number up here. That's right. Run this one. 1, 3, 5, oops, 4, and then my loop stops, right? Loop is done. So stop running here. If I want then to say, there's my count of odd numbers or something like that, we'll start off at 0. We'll say, okay, if my number, we'll just take count of odd numbers plus 1. And when I'm done here, we'll say, we'll print formatted string, you entered a count of odd numbers, right? So we'll just count how many times I've entered odd numbers. And they can enter as many as they want here. So 1, 3, 5, 7, 9, and I do 10. And so I've entered 6 odd numbers. Oh, uh-oh. Well, 6 isn't right here. That's not great here. Not really what we wanted, because it counted 10 even though it wasn't odd. So some things you can do here if you want. You can say, hey, if number mod 2, or really in our case, we want like the opposite. We want to try and illustrate the opposite here. So if it's equal to 0, what I want to do is I want to continue. So continue causes the loop body to stop and to jump up to the loop expression. Right? The loop expression being, are we mod 2? Right? So it will just jump back up to the top. If we don't jump up to the top, we'll count the odd numbers here. Sort of a silly case here. Again, I'm not really a big fan of continue. You'll work with a couple of them in the lab. So 1, 3, 5, 7, 9, and 10. Now we get only 5 odd numbers because we hit the continue, didn't count it here, the loop ended. That sort of thing. There's some good cases for continue, very specific cases. Generally, I avoid continue and break because they are a little confusing, and really you can avoid all of these things by just having other conditions. Like you rarely need to use break or continue. You can use other stuff in code, but it's okay. They totally can work. So just one option here. All right, so let's see. What else do we have here for our loops then? Let's take a look. So we did break and continue. Oh, the loop else. So loop else is fun. if a loop doesn't break, the else value will run here. I don't know. It's not the most interesting thing here. So we can say else print. That's all, folks. So when we run our loop here, the loop ended without a break. It didn't do anything, but it ended without a break. So we get that's all, folks. If you hit a break, then there is no else. So we can say else print this loop else is running or something like that. And we won't expect this one to run because we're going to break the loop. So if I enter 42, it doesn't run because we broke. So else only runs if the loop, we say ends normally or doesn't break. Right, so it's a little weird that you'd have one of these at the end of a loop, but it is valid syntax here. Right, and then the last one here is enumerate. Enumerate's really fun. So if I had a bunch of values here, like so I had some numbers or some values, right? I had, let's do, we have names, right? Do we have a names list here? Eric and Jasmine, Joy, Jeb, Phoebe, on and on and on and on, right? We can list out my family if we wanted here, but if you wanted to get the index values and the values out, what we would usually have done, we would say for index in range length of the names here, right? And I'll get between 0 and 1, so we could print a little formatted string index of index, and value is then going to be my names at the index here. Sorry, in my braces here. Right, so here's the index value I got with index. Here's the value at that index I'm getting out of the list. Right, and we can run this one and we'll see now we all get numbers 0 through 5 or 0 through 4, right? So this is pretty common. If you want to save a little bit of typing, and it's not even really a lot of typing, so I don't really know why you would, but you can. We can do the same idea here with enumerate. So we can get the index and the value in, we'll say enumerate names. Now I get index and value. So here's my variable name for the index. Here's my variable name for the value. It doesn't have to be the word index, doesn't have to be the word value, right? It could be A and B. It doesn't matter here, but right, that's what they are. So I like using that. You get the same thing back out. Okay. Now, just like when you're looping through a list, though, if I change value here, right? If I say value equals value dot upper, and I want to uppercase the value, right? We run that. I'm going to get the uppercase versions, sure. But now if I were to print names again, is it going to have changed when we're done? It hasn't changed, right? So just like when you loop through using a for loop in the values of a list, changing it's not going to change it here. But if I were to change names at index, right, change it inside the list directly, I would be able to change it. This is giving me the copy again here. So even value is a copy from the list. So changing it inside doesn't affect it afterwards. Okay. All right. How you folks feeling? You doing okay? I think that's all the extra stuff for lists or for loops that we wanted to work with. Yep. All right. We got a couple labs enabled. Hey, Professor Burp, how you doing today, my friend? Good to see you coming along here. Let's talk about the next project. We go and add project 1. So we're going to need a new repository link for project 1. Project 1. I need my Python template. Okay. Awesome. Okay, so we'll add a new project. Project 1. So this will be due in 2 weeks then, before class starts. So that puts us at 12:30 p.m., correct? This would probably be worth about 12 points or so, a little bit more. Oh yeah, mobile development's a lot of fun. Android, you can do a lot of fun stuff on mobile, for sure. But Android Studio is just such a hog and super slow. Did it ever get any faster? So please submit the URL to your Python file. Right, and we'll do an online submission for a URL. Fantastic. And give me 1 second. I got to go grab this from over here, if you don't mind. I'm going to do some copy pasting because that's how I roll. But it's okay. You won't mind, right? Let's see. I think it's this one. Yes, here we go. All right, and let's make sure we do this in the right font here. So Comic Sans, gets a lot of hate, but it's actually a fantastic font because it is one of the rare built-in fonts that is more friendly to people with dyslexia, which I've learned all about now that we know my daughter has dyslexia. Really interesting. So we're going to make a text-based adventure game, and not really a good game or anything, styled after the famous Zork game here. So Zork is fantastic. They were one of the original text-based adventure games that has a claim to fame. You would just get text on the screen and tell it what you'd want to do. So you can actually play Zork online. Zork online. There's a little simulator, playzork.com, which is awesome. We'll simulate it here. We want to play it. That's an ad. We can close the ad. Thank you. I just want to play it. I don't want to download anything. Test it out here without it. That's what I wanted. Okay. Uh-oh. Failed to fetch. No, it was working before. It worked last time. Come on, Zork. No! Did it die? Oh, man. Zork, how about this one? There is no download. I don't want that. There's a walkthrough. Come on, where's the link? Text Adventures? Is it this one? We have to try it here. Play online. Oh no, it all links to here and it's not working. I'm so sad. Classic games. We play it online. Is it linked to the same place? It doesn't. Okay. Nice. Is this going to work? What is
if you're voting by mail this year, it's time to
skip the ad. Press any key to continue. Loading the emulator. Okay. We're getting there. Here we go. This is Zork. So it gives you a text description and you get to do something here. So it says west of house. You're standing in an open field west of a White House with a boarded front door. There's a small mailbox here. So we can say like, go west. Forest. This is a forest of trees in all directions. To the east, there appears to be sunlight. You can say go east. You're on the forest path. There's a path winding through dimly lit forest. The path heads north-south here. One particularly large tree with some low branches stands at the end of the path. Go west. Back in the forest. Go north. You're in a clearing with the forest surrounding on all sides. The path leads south. Go south. Back in the forest. Go south. North of house. You're facing the north side of the White House. There's no door here. All the windows are boarded up. To the north of a narrow path winds through the trees. Right, so you can give it some directions to go around it here. So it's an open mailbox or something like that. Oh, you don't see any mailbox. Let's see. Can we go south? The windows are all boarded. Go west. West of house. There's a wall. So we can say open mailbox. Reveals a leaflet. Take leaflet. Read leaflet. Zork is a game of adventure, danger, and low cunning. In it, you'll explore some of the most amazing territory ever seen by mortals. No computer should be without one. Okay, sure. Look around. You're standing in an open field. So you give it text, and it gives you some text back. You can do things with it, that sort of thing. Like open door. Door cannot be opened. Okay, sure, we can't open the door. Can we go east? The door's boarded. We can't remove the boards. Okay, go north. North of house. Look. All the windows are boarded up. Narrow path. Okay, how about go east? Behind the house. Path leads to the forest in the east. In one corner of the White House, there's a small window that's slightly ajar. How about open window? With great effort, you open the window far enough to allow entry. Enter window. Look at that. Now we're in the kitchen. So this idea. So this is we're styled after Zork here. We're going to create several actions and navigation options for the user to play from, and a help option that lets them do some. Oh, not this one here. Here's our DOS box. So if I say help, I don't know. This one doesn't. I thought there was a way to get help sort. Display. I don't remember here. That's the walkthrough command list. Is there a help? Look at that. Look at all these cool things. Save, restore, restart, verbose. I guess there's no item commands, other commands. Look at that. Look how fun this one is. Wand commands. All right, I guess there's no help, so we had to go look it up here. But we're going to add a help here, which will tell them all the things they can do. Now, our game is not going to be as interesting as Zork here. So we're just going to run forever until the secret escape word has been entered. You're not going to tell the user what it is, but if they enter the secret escape word, like get me out of here or whatever you want to call it, then our game can end. So one of the actions will wound the player. If the player is wounded, they're required to sleep before they can continue. The only thing a wounded player can do is sleep. They can't use items, they can't have actions, they can't navigate. After they sleep, they're no longer wounded. It's magic. Each command always gives the same response no matter where they are. So we don't need to be tracking where they are. So like go north will always give me the exact same output. Zork knows where you are. We don't need to worry about that. We're not that fancy. Okay. So for action commands like jump or hide or run or fight, anything you want to come up with is perfectly fine. And for navigation commands like go north, go south, go east, go west, or anything you want here. Option for sleep, option for help, and the secret escape word that ends the game. If the command isn't recognized, we should display the help text. We're going to count the number of turns the player's in the game. Don't count the help command as a turn, and we're going to say, okay, congratulations, you spent this many turns in the game. So essentially, we could say go north, go south, go east, go west. That's 4 commands, and then get me out of here, if that's the secret escape word. It says, congratulations, you got out of the game in 4 turns. That sort of thing. If you say go north like 100 times, and then you say get me out of here, you'll say, hey, you spent 100 turns in the game. Fantastic. If you say help, 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 get me out of here, it should say, hey, you spent no turns in the game because you didn't ever give it a valid command. That sort of thing. Does that make sense? So let me go and save and publish this one here. And then we're going to add a rubric here. So we're going to have, this is for project 1. This will be the 4 action commands for 4 points. And then we'll have 4 navigation commands for 4 points. One of the actions will wound the player, and they are only allowed to sleep. Let's do 2 points for that one, and then number of turns, valid moves is tracked and displayed when the game ends. Ends by entering the secret escape word. That's 2 points there. So total of 12 points, right? You've got your 4 actions, your 4 navigations. You get wounded, you can only sleep, and then we're tracking your valid moves, displaying it when you enter the secret escape word. 12 points total. I think we've got everything in here. Not counting help, right? Having the help here. I guess that's not explicit in the rubric, is it? Do you need a point for help? I guess we can have a point for help. Let's do that. Let's make these 3 each then, and then I'll add one more. The command isn't recognized. Display the help. Don't count it as a turn. We'll do 2 points for that one. There we go. So 12 points. Okay. Now I think we've got everything in the rubric here. That makes sense? So lots of loops here. Lots of loops. Lots of if else, lots of loops. We're practicing those here. Okay. Questions, thoughts, or concerns? Create the rubric, and we should be in good shape. All right, this is what we'll be working on for the next 2 weeks for the project. When we get to class on Monday, then we're going to move on to new stuff. So if we take a look at our schedule here, we are going to be moving on to functions, and then we'll have a lab on functions, and then we'll finish up functions in a week. And then we'll get to strings, have a lab on strings, finish up strings, go over project 1, talk about project 2. So on and on and on. So 2 weeks for all these projects. Just kind of, that'll be the schedule until we get to the final project, and then we'll work on the final project for the last month. And it should be a lot of fun. So believe it or not, this is the end of week 5 here. So we are officially a third of the way through the class. Holy cow. We are just flying through this fall semester here. So let me know if you have questions or concerns. I'm happy to meet with you folks virtually since we're not on campus today. If the regular office hours don't work for you, let me know. Shoot me a message and we can try and arrange something other times. If not, take care and have a great weekend, and I will see you Monday. Bye, everybody.